Good afternoon, everyone, and welcome to MOS Live, Space Edition. Thank you so much for joining us today. In a minute, we're going to invite our presenters to turn on their camera. But first, I want to let you know that if you are watching on Facebook or YouTube, we are so sorry we cannot get to your questions at this time. And if you're watching on Zoom, I want to point you toward that Q&A box at the bottom so you can type your questions about space to our presenters. If you are wanting closed captioning, those are available. You can head to the closed caption or CC button, probably at the bottom of your video. So at this point, I'd like to invite my presenters to turn on their cameras and introduce themselves.
Hi, everyone. My name is Eric. My pronouns are he, him, and my favorite space mission is New Horizons. And that, excuse me, that is a robotic probe that took 10 years to make it all the way out to Pluto. Flew by and gave us our first ever up close look at that world, kept going another 1 billion miles and flew by another tiny little world called Arikoth. And that was the furthest out we've ever explored something up close.
Hi, everyone. My name is Janine. My pronouns are she and her, and my favorite space mission, or at least one of my favorites, because it is really hard to choose, is the one that has curiosity as part of it. I think it's so cool that we sent something so big to another planet and it's roving around and taking cool pictures and doing cool science and letting us know all about that red planet.
And hi, my name is Meg. My pronouns are she and her, and I also find it hard to choose one, but one of my favorite missions is Messenger, which visited Mercury between 2011 and 2015. And it's really a neat mission because Mercury is super hard to get to. It's very close to the sun. It has an eccentric orbit. The gravity is very difficult to get there and then not fall into the sun. And we learned a ton about the innermost planet from Messenger. So that's one of my favorite ones for sure.
Great, thanks so much, everyone. So we're still waiting for some questions here, but I want to start us off by asking what's going on with Venus. I've been hearing a lot about Venus this week.
Yeah, it's been really big in the news the last couple of days. A study showed that there is a chemical present in the atmosphere of Venus that we can't really explain. The chemical is called phosphine, and we have it here on the Earth. It's kind of a caustic chemical, but it doesn't really last that long on the Earth, and there's not really a lot of processes that create it. One of the processes that create it is biological life and those chemical reactions. So finding it on Venus, where we can't explain it with a volcano or sunlight causing other molecules to break up into phosphine, that trace amount high above the atmosphere of Venus, it's kind of exciting. We don't know what it is. It doesn't mean that there's definitely life there, but it's one of those times when that's a possibility that we have to, think really hard about. And we don't know what the explanation will be, but really we should keep looking into it. We should continue investigating. We should maybe send something there to sample the atmosphere. That would be cool.
Yeah, I want to add that one of the co-authors of that study, she wrote that she's used up all of her ideas of what could be causing it besides life. And so other people should come with their ideas and share and join in the fun, which I think is science at its best.
Yeah, I would just add that there is a lot to be skeptical about still. I think you're totally right. We should definitely look into it and study the possibility. But there's always a good chance that this could be a non-biological process that we just don't know anything about. And this has happened before in other cases where we discovered a new molecule somewhere in the solar system, and then it turns out we discover something else that we didn't know before that explains why that chemistry might exist in that place. So it's really neat, and I do hope it encourages a return to Venus, because there's so much that we don't know about our sort of twin planet next door.
Yeah, it's fun. I used to do presentations about space and planets in relation with science fiction. I always talk about Venus and how it wouldn't be a good place to live on the surface, but maybe up in the clouds there might be something. So seeing this evidence of some chemistry that we don't understand happening is pretty exciting. So.
How do scientists get to Venus to learn these things?
So pretty hard to get to Venus, kind of the same as the sun, same as Mercury. If you're going in towards the sun, getting there is the problem. Slowing down and stopping once you get there is the problem. We have had some probes orbit Venus, and we've gotten some really good radar maps, which means you can see through the clouds to actually see what's on the surface, canyons and mountains and things like that. And humans have landed spacecraft on the surface of Venus. One of the longest lived spacecrafts ever on the surface of another planet was Opportunity, that spent 14 years driving around on Mars before it finally stopped sending a signal back. On Venus, the record for longest time a spacecraft spent active there was about 1.5 hours. After that, they just melt, because on the surface of Venus, it's about 900 degrees Fahrenheit, hot enough to melt lead. There's sulfuric acid rain. The atmospheric pressure is 100 times what it is here at the surface of the Earth. So kind of really difficult to investigate the surface. But if we went and explored with a mission that would maybe stop 70 or 80 miles above the surface and kind of float through the atmosphere at that point, the environment isn't that harsh. The pressure is about what it is here on the Earth. The temperature is not that extreme, and we might be able to send some kind of like big inflatable mission to fly around to different parts of the atmosphere. So nothing like that is planned yet, but this might be the news that pushes scientists to start thinking about those missions and actually start putting them together.
Yeah, and there's kind of a way that NASA works with missions where you propose a mission and then there's a whole bunch of missions that get to different stages, and then you find out what the final missions are that are actually getting funded. And so there have been a couple in the past that have been Venus missions that would maybe be in the clouds, and they didn't get far enough because maybe they thought there wasn't enough scientific merit to doing that. Well, now we've got something that's got a lot of scientific merit, so hopefully they'll be able to get those missions further along, and we'll get some funded.
What are the advantages of space travel? Why do we keep pushing those limits?
That's an interesting, broad question. I mean, fundamentally, just the desire to know more about our universe, I'd say, counts as an advantage, even though it's not a material thing. That we want to know where we came from, how the universe formed, how life came to be the way it is. And I think that one of the fundamental pushes behind a lot of space exploration is understanding whether life could have or did exist anywhere else in the solar system. So that's a major question that's driving us. In addition, there's lots of spin-off technologies that have been discovered along the way. So that's a big one too.
Yeah, a lot of the technologies that have come from the space program have improved our lives or saved lots of lives. Not things like Tang and Velcro that you usually think of being associated with the space program, but things like when you get off of the highway and you're on a kind of a really sharp curve, the road is graded and treated in a way that prevents cars from slipping off. And that came about when engineers were trying to figure out how to get the space shuttle to land safely on the runways on the Earth at 250 miles an hour, landing like a plane without slipping back and forth. And they figured out grooving the runway in just the right way gave those wheels a little bit more traction. And then from there, it was, why don't we do this on every road in the world where cars are slipping off? And so at that point in the 1980s, it was kind of applied everywhere. And that has reduced a whole lot of car accidents. So when we do things like study how to communicate with a robot on another planet, or how to keep a person healthy on the space station in that harsh environment, what we learn then gets transferred to, well, that can benefit everyday life. If we can figure out how to keep an astronaut healthy and how to have them exercise more efficiently, we learn more about the human body and we can apply it to more things and just kind of help everything. So sometimes the benefits of space travel aren't really obvious until we see them in action and then apply them at home.
All right,
yeah,
thank
that's
you.
sort of, oh, sorry, I was just going to say, it's sort of how basic science works in principle. A lot of the times, science in general is funded not with a specific material goal in mind, but that as long as you sort of explore the question that is on your mind and that is of interest. And then once you pursue that, in pursuing that, a lot of times you get information that becomes materially useful in an engineering project down the line, and you didn't even set out for that. So just sort of in the same vein as basic science in general, we're sort of working toward the public good on the outset, asking questions that are big and broad and exciting. And then you end up with all these benefits along the way. Space is the same.
So speaking of some of that technology and adventures, Harrison, age 5, wants to know what new horizons passed on its way to Ultima Thule.
So it headed way out of the solar system, away from Earth, the fastest spacecraft we've ever launched away from the Earth at 35,000 miles an hour. It flew by Jupiter for a little bit of a gravity boost and kind of used that as an opportunity to test its cameras while it was zooming by. It just took some pictures of Jupiter. And then it passed by Pluto, which was a planet up until 14 years ago now and is no longer a planet. It's still a really interesting world out at the very edge of the solar system. And we found things like entire mountain ranges the size of the Rocky Mountains here on the Earth, but made out of frozen water, so ice mountains, glaciers made out of solid nitrogen, not as many craters as we were expecting to see, which is really, really interesting, and a whole lot of interesting things, not just on Pluto, but on its moons too. Pluto has a couple of moons, some of them really, really big. And then it kept on flying. It took a year to send all that data back, all those pictures, and then it flew by that far, far away, tiny little world. It was called Ultima Thule for a while. Now it's renamed Arrakis, and it's kind of two blobs of rock stuck to each other. It kind of looks like someone smacked two of them together and they stuck. And we think that's kind of what happened. We think that they formed kind of near each other, and those two eventually just kind of collided really slow, and it kind of looks like a 2-segment snowman. And it also is a little bit different than what we expected. It's a little bit redder, and there's some processes going on that helps us understand what's going on in the very outer part of the solar system. And also, since all that material hasn't changed very much in the entire time the solar system's been around, looking at stuff way out there is kind of the key to understanding what it was like in the early solar system, what the conditions were like, and how things formed.
That actually leads to my next question. I think everything we've talked about so far has been within our solar system. But what does that mean? What is our solar system within the topic of space?
That's a great question. So speaking in the most sciencey way possible, our solar system is everything that is gravitationally bound and orbiting our sun. So solar, sol, the sun, everything that goes around it is part of the system that makes up that whole group. But now the solar system itself, right, is our solar system, but there are other stars out there, and many of those stars have planets going around them. So they have stellar systems. All of those stellar systems are going around, at least in our galaxy, in the Milky Way galaxy, are going around a supermassive black hole. That's at the very center of our galaxy, and keeping all of that stuff going around. So you just keep thinking about things that are going around, things that are going around, things that are going around, things. Then our galaxy is part of a super cluster. And so we really get to see how gravity plays out with objects. But the solar system is all the stuff, including the sun, that goes around the sun.
Thanks. And speaking of the sun, I saw a headline that the sun is entering a new phase or stage. What does that mean?
Yeah, the sun has an 11-year cycle of activity. So when you look at the sun, not with your eyes, through very careful, specific solar filters, because it's very damaging to your eyes to look directly at the sun. When scientists study the sun, you can see that there are sunspots on it. And sunspots are areas where the magnetic activity of the sun is different than the rest of it. And those sunspots create a pattern that changes. It increases in activity and then it decreases again in a roughly 11-year cycle. So They've just, there was just recently news that we believe that the sun is starting another one of those cycles. And yeah, I don't know if anyone has anything else to add to that.
Great, thank you. And going toward the other side of our solar system, we have a question here. Can someone land on Pluto?
We could, sure. That would be hard for a whole lot of different reasons. One of them is that it's super far away. And even though it was the fastest spacecraft we ever launched from the Earth, and we got a slingshot gravity assist maneuver from Jupiter to boost the speed even more, it took that spacecraft 10 years to get from Earth to Pluto. And that spacecraft was about the size of a grand piano. So if we were going to send something big enough for a person to live inside, they would need to spend 10 years inside of something probably not much bigger than the front seat of a car. And we would need to figure out how to keep that person healthy and fed in all that time and entertained. And then the problem is when you get to Pluto, you are going so fast that you just zoom right by. And that's what New Horizons did. It didn't stop at Pluto and go into orbit, which we've done with other places like Jupiter and Saturn. What you need to do is all that speed you built up, turn your rocket around and fire the other way to slow down so that the object you're going towards can capture you with its gravity. For Jupiter and Saturn, that's not too hard because their gravity is really strong. So the speed that you need to slow down to isn't that drastically low. For Pluto, tiny little Pluto, smaller than our moon, you would need to almost stop going from a huge, huge speed. And so you would need a really huge rocket to launch from the Earth in order to have enough fuel when you got to Pluto to slow down. And so instead of launching one rocket with a tiny little spacecraft on top, you would need a fleet of probably hundreds of rockets to fuel up your rocket in space. And then you would go and spend 10 years on a tiny little capsule waiting to get to Pluto. And then you would have to slow all the way down, and then you could land on Pluto. And then you probably want to come back. So now we have to go back to the drawing board and figure out how we're going to get you off of Pluto and all the way back to the Earth another 10 years later. We could do that, but we'll probably aim for other places to go first. We're going back to the moon as soon as a couple years from now with the Artemis program. And we hope to get to Mars as our next target sometime in our lifetimes.
Awesome. So speaking of those closer to Earth targets, what kind of training and preparation does an astronaut have to go through?
Oh my goodness, there's so many things that they need to do. And it depends what their specialty will be on the mission, right? So you have different people who are in charge of different things. And so you might have people earlier on in our space flight history, almost all of the astronauts were like pilots who were like testing out special new fancy planes that were going really fast, like trying to break speed records and all this. So they were like, that was the training, was be a really good pilot, and then we'll figure out how to send you up to space. So now there are more different things, right? Now that we've figured out how to kind of fly stuff, more or less how to get things up, now we have to think about what kinds of work would we want them to be able to do? If they're going up to the ISS, like what kind of expertise might be helpful for doing experiments up there while they're up there? Being able to not get motion sick is helpful. So you'll see the like testing out the gravity spinner and seeing how you do on that. You might have heard of the vomit comet, where they take people up in a plane and then they're making them go down so they can experience what free fall feels like inside a plane. There's lots and lots of different kinds of trainings and lots of different kinds of expertises that are needed in any of these missions. So I think Eric probably has some more to add to that.
Yeah, like Janine said, it's not just pilots anymore that are operating spacecraft. There's lots of different backgrounds of astronauts. Just the astronauts that have gone up in the last couple of years. There have been doctors, because we're doing a lot of studies on how the human body responds to being in space. There have been engineers of all kinds, setting up instruments, testing things out. There have been marine biologists, because they do things like study how penguins can dive and stay underwater for a really long time, how their lung capacity affects other things. And that's related to living in extreme environments, which is kind of like the space station. So basically, if you want to be an astronaut, you have to be really good at a whole lot of things, and then really, really good at a smaller number of things. And then you have to probably learn Russian if you speak English, or English if you speak Russian, because the space station right now has both of those as its main languages, as the United States and Russia are the two main contributors to it. They each have a section on the space station. They need to communicate really well. All the astronauts wear kind of 3 watches while they're up on the space station right now. One is Houston time, one is Moscow time to talk to the Russian segment, and the other one is usually like their home time zone to know if they're going to call their family, what time it is there.
I would just add, one of my favorite aspects of astronaut training is the Earth analog training, where one of the there's no real way to prepare for what it's like to go on a spacewalk, for example, or to put your feet on the moon. But in order to try and prepare as much as they can, a lot of the training that astronauts go through involves finding sites on Earth that are as close as we could get, or at least provide some sort of like an opportunity to go through all of the procedures as if you were walking on the moon, in order to practice all of the things that you need to do and to wear the gear that you would need to try out. So astronauts go to places like Meteor Crater in Arizona, or Craters of the Moon, which is a big volcanic field. And they sort of test out, to the best extent that they can, what it would be like to actually go through a spacewalk, or a moonwalk in that case, maybe someday a Mars walk, in places on Earth that are somewhat similar in different ways. Not exactly the same. Gravity is one big difference.
That reminds me, one of the earliest astronauts, and now I won't remember which one, was a big scuba diver. And so when he went up and he was experiencing microgravity, so when you're in space and you see the astronauts floating, they're not actually not experiencing gravity. What's happening is they're falling and missing the Earth over and over again. So they're just continually falling, and everything around them is all orbiting the Earth and all falling as well. Anyway, so he goes up there, and prior to that, they had trained on these like rigs with all of these cables, so they would be able to like go around and slide out and kind of figure out what it would be like on these missions. And so he goes up and he experiences this microgravity. He's like, this is like scuba diving. And so now all of these astronauts will do this training in these giant pools where they put models, they would put like a model of the space shuttle at one point underwater, and then you're like going around and doing all of your extravehicular activities, your EVAs, and training all of that, but underwater, to train for being in space, which is super cool.
And a little bit more of a specific question, maybe relating to their suits. What happens if the astronauts' oxygen runs out? Could that happen?
So there's a lot of different ways that they have to keep tabs on the astronauts as they are working. While they're out on the spacewalks that they do right now, it's mostly to do things like replace a battery on the outside of the space station, and to put on solar panels and do experiments like telescopes. So there's always 2 astronauts. They're always watching out for each other. And they also have a huge team of people on the ground watching everything that's going on, looking at things like how their heart rate is doing and their breathing and how much oxygen they have left. So before it got anywhere close to being able to run out, if there was a problem and the suit, say, leaking oxygen, then they would just have the astronaut go back inside to the space station where there's plenty of oxygen. We make sure that there's lots there, and we kind of make the oxygen there from scrubbers that take the atmosphere and what the astronauts breathe out. They take some of the carbon dioxide out. They make sure the air is nice and breathable. So it's a little bit of a closed system where we don't have to constantly send oxygen tanks up so the astronauts have enough to breathe. And the system has worked really well. There's been a couple times in recent memory when they've had to stop a spacewalk because something happened. One of the most memorable ones was a couple years ago. There was an astronaut from Italy who started to have his helmet fill with water because a seal broke and water started bubbling up. And so it started to not really fill up, because without gravity, it's not going to fill from the bottom up. But there was water floating around and it started to stick to his eyes and his nose. The astronaut he was on a spacewalk with helped him back inside, and they were able to get him out of his spacesuit and get the water off before there was any kind of problem. And then they were able to figure out what happened, fix it, and make sure it wasn't going to happen again. So it's not just the astronauts that have to constantly look down and see how much oxygen they have left. They have a whole team of people on the ground around the world, really helping them make sure they stay safe.
Thanks so much. And we're actually going to end again with Harrison, who is age 5, who is asking if you have any pictures to share that the Hubble telescope took. So I'd ask if anybody maybe has a favorite to share and tell us about.
Yeah, and I actually saw his question because I was peeking. And so I can share with you one of my very, very favorite pictures that the Hubble took. And this is the Hubble Ultra Deep Field. Hubble stared into space that looks black, looks like there's nothing there for a really long time. And after they compiled all of that light that it gathered, this is the image. And pretty much everything you see in this image, except for the things that have like the crosses, the X's on them, is a galaxy. Which is just like, this was a tiny, teeny spot in the sky. And this is all of the galaxies we can see in that tiny, teeny spot in the sky. And I think it's just beautiful and amazing. And we can learn so much from it. And it's just, space is huge, guys.
I'm glad we got to end on looking out from our solar system. We had a very solar system focused space edition today. All right, that is all the time we have, but I want to thank our presenters and invite you all to say goodbye.
Bye.
Bye, everyone.
Bye. Thanks, guys.
And I want to thank you all for joining us and being such amazing scientists. If you enjoyed today's program, you can find more information about more of our programs to join us next time at www.mos.org/mosathome. And if you would like to help us keep these going, you can support the museum by visiting engage.mos.org/welcome. Thanks so much, everyone. We'll see you next time.